in the sense that, okay, so when we look at technology, sort of the meta idea of technology is you identify some human purpose, for our purposes, so to speak, and then you find some way in the physical universe to achieve that purpose by sort of mining the physical universe for some kind of thing that achieves the purpose you want. That's sort of a meta version of what technology is. Traditionally, technology, as we have built it, has tended to be an incrementally built thing where we have the wheels and the levers and things like that have come from the history of our engineering. But it isn't necessarily the case that you have to do it that way. And in fact, one of the things that we've done a lot is kind of algorithm discovery in the computational universe, where you just go out into this universe of possible programs. You say, I have this particular goal, this particular thing I'm trying to achieve. I'm trying to make something that does some kind of image processing or some kind of natural language understanding or something. And now I just want to find a program that satisfies these objectives I want. And I'm just going to search 1 trillion programs to find the one I want. And very often, what happens when you do that is that you end up getting programs that are that look pretty complicated in their structure. So, for example, in this case, if our goal was to find a pseudorandom number generator, we might very well come up with exactly this system. It's sort of an interesting thing to ask the question, can we recognize whether something was made for a purpose? And so often when you see behavior of a thing, there are sort of two choices about how you can explain that behavior. Choice number one is it's got these rules, it just does what it does based on those rules. Choice number two is it has a purpose of doing such and such a thing, and the behavior it shows is based on achieving that purpose. So the same kind of thing happens even when you talk about physics. You say, you throw a ball in the air, it has a roughly parabolic trajectory. One way of explaining that parabolic trajectory is that there are some differential equations of motion that determine how the ball will move, and that's what determines it. Another approach, and that's kind of the mechanistic explanation, another approach is the explanation that is sort of by purpose, so to speak, and the purpose would be achieve the least action. The action is a integral of Lagrangian, whatever else you want to call it. It's a mathematical construct, and you ask, what is the path that the ball will follow that achieves the goal of minimizing this action quantity? And then you also get a parabola. And you can kind of trade off explaining things in terms of purpose or in terms of mechanism. It's kind of fun to say, if you have a given purpose, so this is an example of cellular automata that have the purpose of doubling the length of their input. So you start with 10 black cells, you get 20 black cells in the end. And this is just looking in the sort of computational universe of possible programs, possible ways to engineer that solution. And it's asking, what are different possible ways that you can achieve that same result? And so you might think, quite reasonably perhaps, that the ones at the top left that happen to be fairly simple in this case were set up for the purpose of doubling the size of their input, whereas the one, that one on the bottom right there, it still achieves the purpose of doubling its input, but it does it in an incredibly ornate way. And you might say, if you saw that, you might say, well, I don't believe that was made for the purpose of doubling the size of its input, but then it might have been that it was made for the purpose of doubling its input, but somebody decided to put some ornamentation onto it because they thought it would be cuter that way or something. It was still made for that purpose, but it was somehow ornamental. And the same issue of identifying whether things were made for a purpose, it shows up all over the place. I mean, it's whether it's the Stonehenge kind of thing, or whether it's the debris on the bottom of an ocean, and you're trying to figure out from some sonar thing whether that's a purposefully man-made thing or not. Same kind of issue shows up all over the place. Actually, when I wrote this big book called New Kind of Science, which talks about some of this stuff, and when I was writing that, one of the things I was curious about is if you look at the Earth from space and you ask, what things do you see on the Earth that kind of show evidence that there's something, I don't know, some purpose, intelligence, something like that? And so I asked, actually, I asked some astronauts I know, for example, what they noticed from space that sort of gives evidence of something intelligent happening on the Earth. And actually, the number one thing they said is in the Great Salt Lake in Utah, there is a single sort of straight line that separates one side that has algae of one color and the other side has algae of another color. And it's a causeway that separates those two sides. It's kind of dramatic, actually, if you look at the pictures, because the colors on the two sides are different. So that's, it's not that spectacular a thing, but it's a definite, straight line that you might not expect to see. Obviously the lights at night are a good thing, except that there are plenty of phenomena that would give you kind of, fireflies or volcanoes or something that happen to build up in particular parts of what you see. And then, actually, okay, I'll tell you another funny story thing related to that. Another feature that's seen is there's Mount Erebus in New Zealand, and this was doing this stuff before the web made it as easy to find information as it does today. But there's this nice circular pattern there. And so we were communicating with the New Zealand Geological Survey about this. And they were saying, if you're writing a geology textbook, please don't say that this circle around this volcano is of geological origin. It is not. It is the boundary of a national park. And the sheep graze, I think, inside that, but not outside. So again, it's a nice circle of human origin, so to speak. But the fact that the Geological Survey was saying, don't say it's of geological origin, it's kind of like it's a fine gradation between those two things. So there's sort of a question of, so I'm talking about the what kinds of things we can find that. How do we know whether things the things that we see were built for a purpose, have a meaning, and so on? Well, or whether they were just sort of selected at random or something like that. So we can take some more extreme cases. For example, one thing we might ask is, let's imagine we look at chemicals. Let's imagine that we detect molecules in space or something like this. And we ask, was that molecule somehow a sign of some what was the meaning of finding that molecule? So one of the questions you can ask is, if you just look at some particular class of molecules, this is alkanes, simple hydrocarbons, and you just ask the question, just in our civilization, so to speak, if you just say each alkane is determined by a graph, you just say you can just generate these graphs, you can generate an infinite collection of these graphs, and you say which alkanes were meaningful enough, interesting enough, to be, for example, listed in chemical abstracts or some source of information about chemicals. Which ones are, and so what you find is that it's sort of interesting because up to some size, kind of all the alkanes are listed. And then above some size, it's only particular ones that end up getting listed. And they're ones that happen to have been used in biology, that happen to have been entrained in biology. And I don't know of any particular regularity that we see here in terms of which ones biology happened to use and didn't happen to use. Same thing actually for proteins in biology. You can ask the question, are the proteins that are used by actual biological organisms special in some way, or are they kind of randomly chosen in the space of all possible proteins? So far as I can tell, they are randomly chosen, but once chosen, they get entrained in all sorts of pathways and so on.